Okay, so here's step 2. This is the calculator section. So if g of x is continuous on this closed interval, and the integral from 0 to 2 of g of x is 9, and the integral from 2 to 6 of g of x is -3, then what is the value of the integral from 0 to 6 of 3 times g of x? Okay? Well, when you do a problem like this, guys, I think that you should probably first notice that you could take the, you could pull the constant out front. So this is, because an integral is really just an infinite sum. And in any sum, if each term has a factor of 3, then 3 is the greatest common factor. So when you do this, you're basically taking out the greatest common factor, if that was not clear. I'm not sure if I made that super clear when we learned this, but okay, so that's that. So basically, if we could figure out the integral from 0 to 6 of g of x, then we just multiply it by 3, and then we have this value. All right? So the first thing that you should notice is that this upper limit matches this lower limit. All right? And whenever you've got two integrals, and one upper limit is equal to the other lower limit, then if you add the two integrals, then you would get the integral from 0 to 6. Okay, so if these match, then you could put the two integrals together. That's called additivity. All right, so I could go like this. I could say 0 to 2 g of x plus 2 to 6 g of x equals the integral from 0 to 6 g of x, okay? But then, guys, they told you that this was equal to 9. And they told you that that was equal to -3. Yeah, so you get that this is equal to 6. All right? So therefore, you get 3 times the integral from 0 to 6 of g of x is equal to 3 times 6, which is equal to 18. Okay, so you have a similar example. Okay, so this one, you've got to use Susan's table, and let's just talk about something for a second. Okay, so write this down. This is the 4 possibilities that you have, the 4 combinations of increasing, decreasing, and concavity. All right, this is what an increasing concave up section of a graph looks like. It looks like it could be part of an upwards parabola. Actually, let's go like this. Okay, so this is concave up, and this is concave down. Okay, so this looks like it could be a section of this parabola, so it's concave up. This one is also increasing, but this one looks like it could be a section of this parabola, so it's concave down. This is a decreasing function, and it looks like it could be a section of this parabola, so it's concave up. And then this one is a decreasing function, could be a section of this parabola, so it's concave down. All right? Now, guys, let's do tangent lines at these points. All right? Okay, so like this tangent line would be like that. All right? And then this tangent line would be like that. Okay. Okay, so we got all those tangent lines. Now, let's look at the concave up ones. For the concave up ones, the tangent line is always below the function, okay? So tangent line always below function, all right? Yes, okay. Thinking. Shoot, I don't know if this makes sense or not. Ugh. Let's erase that. Okay, I feel like I'm not making... Okay, anyway, just draw those and then see what you think. Okay, so draw those and then try to think through the problem. Okay, now this one, you should write all of these down, and actually you really need to know these. These are in your flashcards, okay? Not in this same exact form, but they're in there. Definition of a horizontal asymptote. If you don't want to hear me read it, you could fast forward, but I'll read it if you want me to. So y equals a is a horizontal asymptote of f if one of two cases. The limit as x approaches positive infinity is a, or the limit as x approaches negative infinity is a. All right? Then this one, and you really should think of it like, you need to be thinking in terms of like graphs. So limit approaches positive. Okay, so this would be like, okay, if I was like approaching positive infinity, but I was like leveling off. And you can cross a horizontal asymptote, but you can't cross a vertical one. All right, and then this one, x is approaching negative infinity, so, you know, it would just be like, I'll do a similar graph. Yeah, like that. Okay, a vertical one, though, you cannot cross. Okay, so here is an example. Now let's say, so this time, so x equals a is a vertical asymptote of f if the limit as x approaches a from the left is positive or negative infinity. So here's an example. So let's say that this is a. So I'm approaching from the left, and let's say that this is like negative infinity. Okay. And then this one, the limit as x approaches a from the right is positive or negative infinity. Okay, so I'm approaching from the right. I'll do positive infinity this time. Okay, and then this last one, you also could have the total limit, like from both sides. So the limit as x approaches a of f of x equals positive or negative infinity. I'll do like a volcano graph. Yeah. Okay, so there's just some examples. So you could be like, all right, let's just say example, because I didn't show both cases. Example, example, example. Darn, I said to fast forward through my talking, but I started writing. You can do Susan's table. You can do Susan's table, calculator in radian mode. I recommend using Zoom box. Okay, and if you don't remember what that is, you can ask me. See Salmon Packet Part 1, number 10. See Salmon Packet Part 1, number 12. Okay, I'll talk to you later.